Hello everyone. We'll look into a new chapter or a topic named as syllogism. These are basically as in the exams like NMAT, SNAP, IFT, CMAT, TestNet, and SSC and Bank PO for sure. Okay, so of course at the end of the lecture we would be comfortably be able to solve all sorts of questions possible on syllogism. Going with the normal process of teaching and learning, first we'll understand the concept, then we'll know the rules to solve the questions, and then we'll practice enough questions for further clarification of concept. Okay, now let's see what syllogism is. So what is syllogism, or what do we do in this chapter or in this topic? That a syllogism is a type of a logical argument in which a conclusion is derived. So we have to derive a conclusion from two other statements, and these two other statements are also known as premises. So two statements would be given and you need to draw the conclusion. For example, that we have two premises that all humans must die. So this is the first premise. The second premise is I'm a human. So what conclusion that you can logically or verbally derive that I must die because I'm also a human. Okay, fine. Now the statements of premises are in the form of sum of all, either sum or all, A is or are, B or not B. Anyway, we'll see various types of these statements. Now what are the various methods of solving syllogism? The first method is verbal method. Okay, that we have seen in the first question that all humans must die, I am a human. But the problem comes that in the question they deliberately gives a statement which does not which are not logical in normal world. So you are bound to confuse. So we do not use much of the verbal method. Now the another very logical method is Venn diagram method, but with the complexity of the Venn diagram method we try to avoid this method, and especially in this video lecture we'll learn the tick and cross method. There are some rules, there are some conversion, and you can easily solve all sorts of questions on syllogism. So our focus is tick and cross method. Now let's see. So there are some basic things that you need to understand for using tick and cross method for solving syllogism. Okay, so let's read. This method is tick and cross method because we use ticks and cross. So where are ticks used? Ticks are used to denote sets that are defined. Okay, now you must be knowing what is defined. A defined is something about which you know everything, so that is called as defined. So when we know about some set which is completely defined, or we know all the elements of that set, okay, or in the statement it is given that we know all these statements or the elements of that set, so that set is defined and we put a tick over it. And where we put crosses? We put crosses that denote sets that are not defined. So which are not completely defined, we put crosses over there. Okay, so we'll go and see further explanation of this, and we'll see how we apply all these things. Fine. How a set is defined? We can say it is defined, or we use the term distributed. So remember this. For define, we'll use a term called distributed if all the elements of set have to be known in order to define a particular premise. So a particular premise, a premise is nothing but a statement, and in a particular statement if we know about a particular set and we know completely about that particular set, so that is called as defined or distributed. Okay, now if all the element of set need not be known in order to make a particular statement, that set is said to be not defined. So we'll have statements in which we do not have the knowledge of all the elements of that particular set, and that set would not be completely defined, so that would not be distributed. A distributed set is the one which is completely defined. Hope you have understood it. Okay, so we basically feel or find four types of statement on syllogism questions. Okay, so all syllogism premise and conclusion fall in the following four categories. Okay, first is all A's are B, and we call it as universal affirmative. So we use the term UA even. Now universal negative, that is no A's are B's, so that is also called as UN. So this is universal negative. Particular affirmative, that some A's are B, so this is particular affirmative. And particular negative, that is PN, that some A's are not B's. Okay, now we'll see how to apply tick and crosses for such statements. Let's understand the concept first. Now if you see this, if you read this statement, that the first two in the first two statements are known as universal statements. Why it is known as universal statement? As they specify all the elements in the set. Okay, because if you look into the first two statements, we know about all the elements, all A's are B's. Okay, we know about all A's, that no A's are B's. If we say that no A's are B's, it means that we know all the elements of A's, all the element of B's, then only we are making a statement that no A's are B's. In the first statement, all A's are B's, we must know all the elements of set A. So if we are knowing all the elements of set A, so it is defined, so we'll put a tick cross, and we need not know all the elements of set B, so we'll put a cross. Similarly for universal negative, no A's are B's, so we need to know all the elements of A's, all the elements of B's, so we'll put tick on both of them. Particular affirmative, that some A's are B's, some A. So in this statement, we do not know all the elements of A's, we do not know all the elements of B's, so we put a cross marks on both of them. Now particular negative, some A's are not B's, some A's are not B's, so we need to know all the elements of B's, because to make this statement we need to know all the elements of B. So some A's are not B, so we'll put a cross over here. Okay, let's understand more further so that you don't confuse and you don't forget. So let's look into the first statement, like all A's are B's, which is also called as universal positive. So the example of this statement would be, we know all the elements of A, 1, 2 and 3, and we have all the elements of B, but we do not know the complete elements of B, but it is 1, 2, 3 and dot 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 to infinity or whatever. But to make this statement, we need to know all the elements of A. So in such a case, set A has to be completely defined. That is why we are putting tick over A and cross over B, because we do not know the complete element of B. Now again, no A's are B. Fine. If no A's are B, so we need to know each of the elements of A and B to make this statement. So set A is defined completely, set B is defined completely. When two of the sets are completely defined, they are said to be distributed. When we know there is a distribution, so we'll put a tick over both of them. Fine. Now let's look into the third statement, some A's are B's. Okay. So this is also called as particular positive or particular affirmative. Some A's are B's. So we do not know about all the elements of A, we do not know about all the elements of B, but we know that some of the elements of A are there in B. Similarly, or vice versa, some of the elements of B are there in some of the elements of A. So but none of them are completely defined, so we'll put a cross marks over both of them. Now let's look into the fourth statement, some A's are not B. So this is also called as particular negative, because we are using the term not. Anyway, so some A, so all the elements of A are not defined, but we need to know all the elements of B to make such statement. We can see that 1 over here is not present in A, so some A are not defined. Of course, we do not know the complete element of A, so this is not defined completely and this is defined completely, so we'll put a cross mark over here and we'll put a tick mark over here. So this is the way we need to memorize. So this complete table should be memorized, that where to put the tick mark and where to put the cross marks. We have just 4 types of the statement, that is universal positive, all A's are B, universal negative, no A's are B, particular positive or particular affirmative, that some A's are B, particular negative, that some A's are not B's. So you just need to memorize these 4 types of statement and how to put cross marks and tick marks over each of the attributes or sets in these statements. Fine. Now let's look into a conversion concept in these statements. There is a conversion concept. Let's try to understand this. So we'll look into the conversion of each of the following sorts of statement. The first statement is universal positive statement, which is, for an example, let's take all cats are dog. So can I write all cats are dog in this form? Because in the previous slide we have seen how to denote crosses and ticks. Now what can be further conversion? Now to go for the understanding of conversion, roughly it is nothing but a tick can be converted to a cross, but vice versa is not possible. It does not mean that a cross can be converted to a tick. Always a tick can be converted to a cross. Fine. So in this case, if we convert a tick to the cross, we'll get like this. So this statement, or this shows a particular statement. What is that statement? Of a particular positive statement, which is some cats are dog. So we can say that some cats are dog. Now when we are saying some cats are dog, we can interchange C and D, and we can also say that some dogs are cat. So both of the statement is possible. Also a universal positive statement can be converted to a particular positive statement. Remember this. Now let's look into the another sort of statement, in which is universal negative statement. Universal negative statement. No cats are dog. For such statement we put tick on both the attributes. So no cats are dogs. So first of all we can change the order. First sort of conversion in universal negative, that we are changing the order, that is dog and then cat. And how would we say this statement? As no dogs are cat. No dogs are cat. So a universal negative statement is converted to a universal negative statement, but the order is changed. Now let's try to look for the conversion of tick to cross. So we have our initial statement as cross, a tick on both of them. Fine. Now especially for universal negative statement, remember this, especially for universal negative statement, when we are converting tick to cross, we follow 2 steps. First step is to change the order. Okay. So when the order is changed, D is at first position, C is at the second position. Now the second step is to put cross in place of tick, and we'll always do that with the first set. So it would be cross and this would be a tick mark. And how do we say this statement? The first is cross, second is tick. We say that some dogs are not cat, and this is what? Particular negative statement. So what do we get to know? That a universal statement can be converted to a universal statement, a universal negative statement, also a particular negative statement. Okay. So also if you observe, a negative is converted to a negative statement only. Fine. So remember this 2-step conversion of universal negative to particular negative. Fine. Now let's look for a particular positive statement. The example of this is some cats are dog. So some cats are dog. So cross on both of them. There is no tick to convert. All we can do is to change the order. When we change the order, we can say that some dogs are not cat. So a particular positive statement can be converted to a particular positive statement only. Fine. So that is it. Now we have the fourth statement, which is particular negative statement. Particular negative statement, that is some cats are not dogs. Some cats are not dogs. So this is how a particular negative statement is denoted. Now always remember that a particular negative statement cannot be converted. There is no conversion for them. A particular negative statement cannot be converted. Now let's sum this up. What we know, that a universal positive statement can be converted to only particular positive statement. Universal negative statement can be converted to both universal negative and particular negative. Particular positive statement can only be converted to particular positive statement, and a particular negative statement, it cannot be converted to any other form. So this is the rule of conversion. If you have not understood this completely, go back and see this complete section of conversion. All you need to remember is this table of conversion in the end. Fine. Now we'll look for the rules to solve the syllogism questions. So the first rule is there should be exactly 3 terms in the premises and conclusion put together. So A, B, B and C. So if we have 2 statements in such a form, then only a conclusion can be drawn. Okay, and there are further more conditions for it, but there need to be exactly 3 terms in premises and conclusion put together. Now the second rule is, if both the premises are negative, either particular negative or universal negative, then we cannot draw any conclusion. If both the premises are negative, in negative I mean either universal negative or particular negative, then no conclusion is possible. Remember this statement. The third rule is, if both the premises is particular, if both the premises are or premises are particular, then will have no conclusion. So we'll apply these rules and solve. So these are the rules anyway. Fine. The fourth rule says the middle term. So what do we know by middle term? The term commonly present in both the premises. The term commonly present in both the premises. If this is our statement 1, this is a second statement. So B is a middle term because it is commonly present in both the premises. Must be distributed at least once. So this is must be distributed at least once means what? It should have at least 1 tick. Okay. Now the fifth statement says, if one of the premises is negative, if any one of the premises is negative, then the conclusion has to be negative. Perfect. So if any one of the premises is negative, then the conclusion would be negative. Now the sixth rule is, if one of the premises is particular, if any one of the premises is particular, then conclusion has to be particular. So if you are making a note, write all these points so that at the end of the preparation you are able to revise everything. Now the seventh point is, a term is not distributed in premises cannot be distributed in conclusion. So a term that is not distributed in premises, so we do not have a tick on a particular term in the premises, that cannot have a tick in the conclusion. Okay, so very clear. You need to remember all these points. So let's sum up or take a note of all these rules. So the first point is the first 4 rules. If you look into the first 4 rules, it helps us to determine if a conclusion is possible or not. Okay, and the last 3 rules help in determining the nature of the conclusion, whether it would be a positive, whether it would be particular, okay, whether it would be negative or whatever. So the first 4 rules helps us to determine if a conclusion is possible or not, and the last 3 rules help us to determine what would be the nature of the conclusion. Fine. Now the second note that we can take is, if conclusion based on considering both the premises, the middle term will be absent from the conclusion. Okay, if we have 2 premises, then the middle term will be absent in the conclusion. It means that, for example, A, B, B, C. So if we draw a conclusion, of course conclusion would be connective. Conclusion would be something A and C. We do not know if it is a tick mark and cross marks. We are not getting into it. We'll use this further, okay, in the examples and see how it happens. But the middle term, which is B, is not there in the conclusion. Also, we do not need to rely on the factual knowledge. Many a times, in fact all the time, the questions are made to confuse you and make sure that you apply rules to solve the questions and you are not biased by your opinions. The information is most of the time fictitious, and there may be circumstances where ticks and cross method will have to be coupled with basic levels of verbal ability, that we have seen that, you know, it may not be all A's are B's. It says every A's are B's. Okay, so a statement may have to be converted in the form of tick and cross method before and then solved. Now we'll look into some of the examples. We'll look into at least 10-15 examples and apply all these rules and the conversion rules and solve the questions of syllogism.